Hello boys and girls. In this video we are going to go through the revision of the work which I gave you. Let's see what kind of answers I was expecting. We start with the CPU, mentioning the Van Neumann architecture. Let's identify three registers which we have learnt about. There is not much to say, but to remember the work which we have done. So we have our accumulator, we have the current instructions register, and we have the program counter. These are the registers we need to remember. Now, what is the purpose of the CPU or the processors or sometimes the microprocessor? What is its purpose within the computer system? Well, the processor is processing instructions which are also software or data. That's what the CPU is doing. Another way to say exactly this is to say the processor is perform the fetch, decode, and execute cycle. So the fetch, decode, and execute cycle is exactly the same as saying to process instructions or data. Instructions are the software, and the data, it is the data which your software is using. Then we go to C. We have three computers with different specifications. Now, if you look at computer A, it has 4 processors, and each processor has a clock speed of 2.1 gigahertz. We go to computer B, it has 2 processors, and each processor is capable of 2.5 gigahertz. Then we have C, which has just 1 processor, and that one processor is blazing fast, 5.2 gigahertz. Okay, now, which computer is most likely to execute more instructions at the same time? We want to find the fastest computer between these three. And if we look at A, it has 4 processors, and if we combine the clock speeds of the 4 processors, we find that 2.1 times 4, we get 8.4 gigahertz. So the 4 cores of computer A can process 8,400,000,000 instructions per second. This is the fastest computer. Yes, these cores, they need to communicate with each other, so they will not really reach 8.4 gigahertz. But we are going to stick to an ideal situation, a theoretical situation, and we will just go with the 8.4. So computer A is the fastest, and the justification is okay. So computer A is capable of dealing with 8.4 instructions per second, and at every clock cycle, computer A will be solving 4 instructions. So at one given time, computer A is moving 4 instructions. So it can do more simultaneously. Explain why computer C can execute more instructions per second than computer B. Well, if we look at computer C, it can do 5.2 billion instructions with its single core. Then computer B can handle 2.5 per core. In total, the two cores will do 5 billion instructions. So 5 billion is less than 5.2 billion. That is the challenge of computer B. Alright, so C is a higher clock speed of 5.2 gigahertz compared to 5 gigahertz for B. Now, C can run 5.2 billion instructions, B can run 5 billion instructions. So C can do more in a second compared to B. We move on to look at the instruction set. What is the instruction set? Each processor has a number of processes which it can understand. And the instruction set is all the processes, all the instructions which a given processor can understand. That's the definition we are looking for. We look at the ATM. The ATM is an embedded system. An embedded system is a computer system which is part of a larger mechanical or electrical system. So what features of the ATM makes it to qualify as an embedded system? There are many features. Like embedded systems are known to have few tasks. We can say few dedicated tasks. Embedded systems, they don't do a lot. It's like your washing machine. The computer on the washing machine can only perform a few functions, doesn't do much. So that's a feature to talk about. Embedded systems are known for how difficult they are to reprogram. So they are difficult to reprogram. Embedded systems, they have sensors. They have input-output. I'll just call it I/O for input-output. Embedded systems, they have programmable platforms like a processor. All these are features of embedded systems. Programmable, we also have the human interface. So we are just going to call it the interface. The human-computer interface. Other features which we can talk about are presence of a processor. Embedded systems should have a processor. All right. Next question also asks about characteristics of embedded systems, and we find that we can list all these features. These are characteristics of embedded systems. And we can add more. Embedded systems, they are capable of real-time feedback or real-time calculations. So that's another feature. All right. Embedded systems are cheap. They are really small compared to the normal CPUs, so they are cheap to manufacture. They cost less. They are not easy to reprogram. I think we've mentioned that. They can perform few functions. We have mentioned that. They usually work with limited human intervention, so they are automatic. They work with limited human intervention. Think about your microwave You leave it to do its thing. When it's done, it switches off. Some of them, they even open the door for you. So that's automatic. Usually, embedded systems, they are part of a bigger mechanical or electric structure. So that's another characteristic to consider. Let's go to 3 examples of embedded systems. We find these in freezers, the lighting system, and the vending machine. The rest are actually general computers. Laptops, PCs, smartphones, these are general computers. They can do a lot, so much that we cannot consider them to be embedded systems. Then we go to question number 3. We have to identify statements which are incorrect. If we look at statement A, this is very correct. The PC stores the address of the next instruction to be accessed. Very true. We go to statement B, the MAR stores the instructions. Well, MAR stores addresses of the program that is running. No. The MAR stores the address of the program that is about to be fetched from the RAM or memory. So B is incorrect, and we are going to correct it as. So that is the correct statement. We are storing addresses, not instructions, of the program to be fetched from memory. You can say program that is currently being fetched from memory. That's also correct. We cannot say the program that is running. The program that is running will be found in the CIR. All right. Then we go to C. MDR stores the data that is passed to it from the PC. The PC stores addresses, so it cannot pass data to MDR. No. MDR's purpose is to store data that is coming from the memory. And by memory, we are referring to the RAM. So C is also incorrect here. And the correct statement is the MDR stores data passed to it from the RAM. That's where the data comes from. Then lastly, I wanted to see people who watch my videos, and these are very important videos. We are actually covering syllabus material. And I had to do videos because not everyone is able to come to my class after school. Some of you use the bus, some of you are picked early, so we had to find a way to include you by making videos. So please take them seriously. Now, what is a variable? This is a named memory location. You can just call it a memory location, named memory location. So, if we have a memory location with a name, and the contents of that location are capable of changing as the program runs, then we can refer to that memory location as a variable. If the contents cannot change during the running of the program, then the memory location is called a constant, which is named memory location whose contents cannot change during the running of the program. Okay, so that's the definition of the constant. Let's look at naming variables. The variable name, if you are storing the name of class teacher, you can come up with different names, but they should be meaningful. I'll give an example. You can say class underscore teacher. You can also use the camel case notation and say class teacher. And please note there is no space here. It's just my handwriting, but there is no space here. Your favorite subject? Don't say it's computer science. No, the variable name will be favorite subject. So you can also use the camel case. Class captain's name, you can just say captain, or you can say class captain using the underscore or the camel case, like class subject. You need to study more. You can just say subject, or you can say subject underscore to underscore study underscore more. You have to pay attention to the conventions we mentioned in the previous video. That is the most important thing. The name you give here may be different from the ones I have written on as examples here, but as long your examples follow the conventions, I will mark them correct. Someone can just say, instead of saying class underscore teacher, someone can say teacher. That is also accepted. So variable names can be flexible. You can have your own name that is different from mine, and I will be okay with it. Then we go to number 6. Your name, this is the variable name. What is missing here is there is a space between the two words. We should put an underscore, or we should use the camel case. For example, we should have your underscore name, or you can have your name. All right. One subject. Variables cannot start with a number. So the problem is this thing starts with a number. Teacher name 8. This is a special character, and special characters are not allowed. So this has a special character. Then we have this number here. A variable name cannot be just a number alone. If you want to have a number within the variable, you start with letters, then you put numbers in the middle or at the end. Otherwise, a number alone is not accepted. So the problem here is numeric only. Then the data types, we mentioned the data types. We have the string, we have the character, we have the real, we have the integer, we have the Boolean, and we have the date time. All right, so that was it for this paper. I hope this makes a difference. Please do the corrections and give me those corrections. Bye-bye.